Alex RBE for a while, but the last couple of years I've been in San Francisco working for Twitter. You can reach me most easily on Twitter at rcoder. Many people don't realize this, but it's not actually Ruby Coder. It's run in Coder from a consultancy I had many years ago. But I have been using Ruby for a pretty long time. Got involved 2003, 2004 or so. At least that's the earliest emails I can find mentioning PDX Ruby. So that seems to be the best date I can use. So I work at Twitter. I'm an engineering manager. I'm one of the bad guys now. I not only don't write code, I work in the ads department. So please feel free to have lots of preconceptions about everything I'm about to say and throw stuff out, heckle, whatever makes you feel better. I've worked a number of other places that used Ruby. Actually, on this list, all but one of them, most of what I did was Ruby and largely Rails engineering.
Yeah. Patrick says hi.
Oh, awesome. Yes, so been doing it for a while. Been doing a bunch of different Ruby stuff, and as you can see, not just Rails. So, if you've seen talks from many of my esteemed colleagues at Twitter, if you've read stuff on the internet, you may believe that Twitter doesn't use Ruby anymore. That is patently false. Like, we have modified how we use it. We don't use it for everything, but I manage 20 some odd engineers, work really closely with another 30 engineers, all of whom use Ruby every day. Out of the, 750 engineers at the company now, I'd say probably half still regularly write non-trivial amounts of code in Ruby, and huge portions of our infrastructure depend on it. So the kinds of things we do with Ruby, we've got the sort of infamous giant Rails app that ran all of and still runs a good bit of Twitter.com and the Twitter API, affectionately known as the monorail, for the monolithic Rails application. There are many wonderful Simpsons jokes that can also be derived from this name. What we do now, not just sort of supporting stuff that's already in place, that's the bulk of our new Ruby development, is some of our lower to mid-scale applications, the stuff my team works on for ads and analytics. So that's campaign management tools, dashboards, a bunch of user-facing stuff and internal tools. A bunch of our international engineering code, Translation Center, which is like a crowdsourced tool where we let people translate Twitter for us. That's a Rails app. Our user support center is a Rails app. A bunch of our mobile web infrastructure is actually Rails. So it is definitely not gone away. It's also the core of most of our deployment and release automation. We have some projects and groups that use Capistrano, some that use a bunch of homegrown deployment code, but all of our change tracking, alerting, Campfire bots, like everything else that makes deployment and release go, that's Ruby for the most part. We have a lot of automated testing, regression tests, integration tests, black box tests, Selenium, WebDriver tests, all that kind of stuff that's written in Ruby. We've heavily decomposed Twitter into a bunch of back-end services that all do sort of one thing. This stores tweets, this stores timelines, this stores DMs. But when you want to just do development locally, you don't want to spin up a whole data center on your laptop, right? You don't want to have 15 services all running with separate processes. So what we tend to do is write little dummy services in Ruby and then use a Foreman script to boot those up on your machine. So you do have a bunch of processes running, but they're all very small. They're all returning dummy data. And you don't have to be able to reach the production data center to work with them. So to give you an idea of the scale of our sort of ongoing commitment, and this is a total wild ass guess, I may get in trouble when the video of this is online if somebody comes to me and says a million lines of code. No, you're totally wrong, it's 2, or it's 500,000, or whatever, but it's on that order of magnitude, right? Like the monorail is really, really big. In addition to the actual Rails app code, it has a completely forked and mutated version of Rails 2.0 point something. That's actually what it runs on. So we get to have the fun of oh, there's a new security advisory for Rails, time to backport, which we do in-house and maintain. But between that and the Ad Center and the Translation Center and those other things, I'm confident we've got 1 million lines of Ruby floating around. We've got about 15 open source libraries on GitHub for Ruby right now. A few apps, but mostly it's client libraries. I mentioned already we do a lot of this service decomposition, and a lot of those services are actually somewhat reusable outside of Twitter. You may have heard of Kestrel, which is our message queue system, Gizzard, which is our MySQL sharding service. These kinds of things, we tend to build those in Java or Scala, But then the first thing we do after that is write Ruby bindings, because that's what all of our systems need to use to talk to them. And then whenever the backend system is open source, we try to make sure the client bindings are open source too. And just reiterating what I said before, we've got hundreds of people like every day plugging away at a few like Ruby source repos. So a lot of what I'm going to talk about is sort of the coordination and social and like non-technical headaches that causes. But yeah, we're like, even in our degraded usage of Ruby, we're probably still heavier users of it than most companies out there. So the stuff that we just sort of really don't even seriously consider using Ruby for these days, if it's a service that we hit at least once for every API request to twitter.com, you're going to have a really hard time convincing anyone that you should be able to build it in Ruby. There are legacy services which get an exception, but the general rule is if it's one-to-one with page requests or more than one-to-one, then it needs to be on top of the JVM or something custom. We don't use it much in our Hadoop infrastructure. So for anyone who isn't familiar with it, Hadoop's a MapReduce system based on a bunch of papers out of Google, the Yahoo open source. It's how we do.
Any use of WooComb at all? Or no?
No.
It's all straight Hadoop?
Well, so we have a bunch of frameworks sitting on top of Hadoop. They're all designed to be sort of native JVM languages, because we try to be, when you've got 1,000 machines in this cluster, even small differences in CPU efficiency get magnified, right? And the cost is really high, and everybody wants to funnel their jobs into that same cluster. So we try to be really stingy with compute cycles on the Hadoop cluster, and that makes most Ruby stuff not super well suited. And then as a subset of like Ruby and Rails usage, even within Rails apps, even within like new greenfield Rails apps, we try to be really stingy with how we use Active Record. I've got some more detail on that coming, but like we'll totally use Rails to prop up a new website, and very seldom use Active Record for the bulk of the model persistence.
But there's this massive history streak that makes you still use it some.
Sometimes. We have toy apps, right? Like we have things that people build during Hack Week, and they just want to plunk it on top of a database, and like that's fine. But yeah, nothing major for production. And then of course, we've got the rest of the usual complementary languages you'd expect to see for a big web business. JavaScript is everywhere. Java and Scala are roughly equal prominence these days. They get used for different types of projects, but in pretty consistent volume. Python has actually become a big thing in like the last year or so. My personal theory is we're hiring so many people from Google that Python has sort of come in that way. But there's stuff that it's really good for, system scripting, whatever, and I've used it a ton too, so I don't really mind. Then C and C++ as we go further down the stack. We're working a lot at the kernel level, the storage level, that kind of thing. So of course we have to work with those. And then pretty much anything else that somebody builds a Skunkworks project in suddenly becomes a language we have to support. So that happens too. So sort of as other people have probably encountered most of these steps, maybe minus the last bullet. But as your site sort of grows from prototype to some people are using it to, a lot of people are using it to, oh my God, now we've got 100 people working on it, whatever. Roughly these stages, I think, are pretty consistent, and certainly these are the ones that Twitter more or less went to. So the first thing you do is just throw more cash at it, which is great, except when it's not. Then you start throwing things in queues. You have your asynchronous workers, you have your job queues to like move stuff out of the request response cycle. And that's pretty awesome. That'll actually get you a really long way. Until you have stuff that really you just can't do out of your Rails stack or out of Ruby at all, or maybe it really needs to hold all of its data in memory, or it just doesn't map well onto like a normal Rails architecture. So then you start doing service-oriented architecture. You have a bunch of single-purpose services sitting behind your app that you're talking to on each request. This probably constitutes where 75% of engineering work for like product engineers goes at Twitter these days, is building these services. And the web tiers really become sort of just a thin layer in front of those. At some point you may decide, you have this brilliant idea that you're just going to rewrite the whole damn thing, because just selectively pulling things out isn't working anymore. We're actually kind of in the middle of one of those for twitter.com and the API. So the bulk of that is actually moving onto a Scala-based framework. That is a huge pain in the ass. If you don't have to do it, I certainly don't recommend it. But sometimes it's just the most reasonable thing. And then you get to a certain size and level of engineering resources, and you can start doing crazy things like building your own database backends, tuning and hacking on the kernel for your OS, building your own async IO libraries, like all this kind of stuff that's super fun, and everybody really wants to work on it. And only about 2% of the folks in the company ever get to touch it. But yes, that's sort of the stages we've gone through. And some stuff we've learned along the way going through all of these. So, the classic question, can Rails scale? Of course it can scale, absolutely. Just keep throwing hardware at it, it'll be fine. But there's a real cost to that, right? And it's not just hardware. Like, horizontal scalability is great, but some of the other stuff I'm gonna talk about, Rails systems get sufficiently complex at some point that the cost of developing them goes up exponentially. The cognitive load of trying to hack on a 500,000 line Rails app is really, really high, even ignoring any external dependencies that it has. So that's something to keep in mind when you're trying to think about whether it can scale, like know that one big system will have extra costs. So I've got this idea of inertia here, which is really the difference between doing something new, like ramping up a new process or tool, and doing sort of what you're already doing. Right? So there's cost to building a new system, to getting it running, to trusting it. There's less cost if it's a system you already sort of know and you know what's good and bad about it. If you always give into inertia and you do the easiest thing to get something out the door, it's going to be one more model, one more controller, one more view in your Rails app, and then suddenly it's huge and you don't know what to do with it anymore. This is more of an organizational scaling thing, but again, like as the amount of code in your system increases, it gets really easy, and as the number of engineers you're working with increases, it gets really easy to fall prey to really rampant not invented here syndrome, right? Like, oh, well, this library exists, but it's not exactly what I need for this space, so I and this other guy are just gonna go spend 2 months making the perfect replacement for it. And that's occasionally really valuable and really cool, but it can, like, minimize it, right? Like watch out for it. And then I'll talk more about this, but if you're working at a small scale with a small amount of code, small number of servers, whatever. Oh yeah, sorry.
So about the non-invented here syndrome,
Yep.
have you found that happens even between teams in the same organization?
Totally. Yes. That's part of the problem. The organization is so big that this team doesn't talk to this team, and so they're working on parallel implementations of the same thing, sometimes in the same language, and like you really want to minimize that. And then metrics get really, really important. When you're working on a small system with a small number of servers, you can basically read every line of source, read every line of the log files. Doing a deep dive to figure out what's going wrong is just like a brute forceable problem. That's not true when you have 50,000 unicorn processes running in a data center, and some of them are erroring out, right? Like you can't go digging through that haystack to look for what's wrong. So your first and best weapon there is to have aggregate metrics about the current behavior, expected behavior, past behavior of your system, and then as things change, you watch those metrics, and that's your signal that something's wrong, not streaming log files where you start picking out stack traces. And then there are some purely human and organizational scaling issues, right? When you're dealing with a ton of people, like hiring and training. Like I've hired 30 people onto my team in the last 2 years. And all of those people have to understand our non-trivial amount of code and how we develop stuff and how we work with it. Part of that is code quality and consistency, making sure you don't have islands of code that are written totally differently than this island over here. That's actually a hard problem that takes like ongoing work to stay on top of. And then there's just the coordination overhead of this many people shipping their stuff into production, hopefully very often, right? We peak at 8 deploys a day, roughly, today, which is pretty good. But it means there's that many deploys for people to know about and either get on that wagon or not get on that wagon for that deploy. Your on-call rotation can become crushing because the rate of change is so high. And the dependencies you have on other services and other teams can be tough to manage. You may not know that a thing you're shipping is going to affect this system owned by another team because you haven't talked to them in 3 months and they've just been executing on their own. So you need some tools and process in place to sort of deal with that. And the need for it and the cost of it gets higher as the organization gets bigger. So in terms of like some things you can do for mitigation, how many people here do code review on everything that goes live? Wow, guys, okay. It's not that bad. It's really not. You can make it really fast and really painless, and it saves you from so many problems.
Are you using a specific program?
We use Review Board for the most part. A few teams use Jarrett. GitHub pull requests are fine.
I don't like the one we're using very much.
Okay.
And everything goes through it, so.
Sure. So yeah, I mean, tooling is very important here, not just like the web view that you're going through and like looking at the code, but you want good command line tools for creating a review, so you don't have to like paste a diff into a text box or something stupid like that. It should integrate with your ticketing system, so that if you're working on a bug or a branch and you create a review and the review gets marked shippable, that all percolates through. So it's worth investing some time into automating this stuff and making it good so that it's really painless to use. Because then the only work involved in a code review is actually reading the code and talking about it. And that should actually be pretty interesting and fun and like not too disheartening. But yeah, please do more code review. Sorry? So there's the sort of default, which is 2 engineers who did not write any of the code in the diff or branch, looking at it and saying, this looks good to me. That's sort of our normal baseline. The exception is we have this thing called an owner's file that can sit in any repo, in any directory, and sort of gets applied to child directories unless something below it overrides it. An owner's file is a set of usernames for folks who are considered experts in that subsection of the repository. If you create a review that touches a file inside that child directory, all of the owners automatically get added to the review, and at least one of them should sign off on the change before it goes live. So again, it's a little bit of tooling and a little bit of process that sort of codifies this finding the expert in this particular subsystem and getting their sign off. Yeah?
Free tools for managing the process like you got here with 3D.
So we just have a bunch of in-house, it's like a Ruby script that sits in an in-house utility repo that knows how to talk to Review Board and Jira and like the other sort of systems that need to be notified about this, and how to parse the owner's files and that kind of thing. It also triggers some other stuff for us, like uploading new translatable strings and kicking off CI jobs and a bunch of other things that sometimes you want to have happen within development branches. Yeah?
Is that owner's file similar to GitBlame or?
No, so you can use GitBlame as a way to sort of update and evolve the owner's file. Like it's a useful exercise to go through every so often, and first you want to prune usernames for folks who aren't around anymore from the file, and then you want to go add usernames for folks who've maybe taken over ownership. We don't have an automated way to do that. I think it'd be an interesting thing to explore. But it may be, just somebody who once upon a time sort of did the review, like owned this thing, shipped the first version, and they want to be aware as stuff evolves and changes. So yeah, we do code review, pre-deploy code review for everything that goes out the door. We do design review for any new system. So before something's actually gone live, we've got a fairly lightweight process, but the idea is get the people who are working on implementation in a room with somebody from ops, somebody from security, somebody from any infrastructure group that's going to be affected. And this is like sort of a last check on sort of the assumptions of the engineer doing a particular chunk of implementation. Again, this is important because you may have dependencies on 20 back-end systems, and you haven't hacked on those systems. You don't know what their capacity limitations are. You don't know how they deal with like certain request rates or whatever. So, I might go into a design review with the design doc saying, I'm going to add this field to all of our logs so that I now have this like dump of the user session. Somebody from the Scribe team, the folks who manage our logs, will put up their hand and say, how big is each of those records? 4K, and how many times are you going to log in a second? Okay, well, that's fine, but we've got to go rack these extra boxes and change these quotas for you. So it's just a way to catch that stuff, hopefully before something goes out the door.
And then security people say, and what's going to be in those?
Totally, yes, no, absolutely. And security is deeply, deeply involved in the design review phase, and they're awesome. Our security team is great, and I love working with them because they catch all kinds of stuff that my team would like to go through otherwise. Yes?
So how do you know what needs to trigger a design review?
This should really be any non-trivial new thing. Like if you would take an hour over lunch to talk over the design of something with folks, it's probably worth putting them in a room with a whiteboard and access to the code to go through it. We have this idea of a much more sort of heavyweight structured software development life cycle that has this and a bunch of other things in its life. Most projects don't actually go through that unless it's a major new, one of those things that's one-to-one with API requests, that'll go through the full cycle. But this would be like I'm building a new, settings page in this app, and it's going to touch these 2 back-end systems, and it's going to store this new data in these tables. Like, that's probably enough to warrant at least writing a short design doc and getting some folks in a room to talk about it. And it's also a way, it's not just so that you can get complaints from people, it's also so you can sort of push awareness that this thing's going to happen out so that people know, and when they hear about it in an after-hours incident or whatever, they have some, oh yeah, I remember there was a design review for that, let me go find the design doc and read about it, see what it is, figure out if it's critical or not. And then we have this sort of purely social protocol that happens around anything that's going live on the main site, right? If something's going to change on twitter.com or on the Twitter API, you are and you are one of the folks who worked on that change, you are parked in what we call Launch Campfire, which is a room that's just for folks who are watching their things go out the door that day. If you're not there to acknowledge, like, yes, I'm here and this is ready to go out the door, it gets yanked from the release. You can have a proxy there, you can have somebody else cover for you if you're on vacation or
Can you have
whatever.
a bot?
What's that?
Bot?
You could, sure. You could write a bot that just said, yeah, I'm here. Yeah, ship it. Which would work great until there was actually a problem and your branch started failing CI at the last minute and they started interrogating the bot about it. It becomes
a good bot.
Yeah, so if that's where you wanted to spend your time, writing the bot.
All your changes are estimated.
Yeah, so the way we tend to do release management is we have a queue of branches that have gone into CI. They're all green. They're all marked as shippable in a particular day's bundle. And this is more, again, for the main, like Twitter.com and Twitter API side. Those branches each have an owner. They're the person who posted it. Those get dropped into an integration branch and tested. And then there's a little bit of like, binary search to figure out what's actually broken, but we'll re-roll the release branch with particular branches cherry-picked out of it, sometimes a couple of times in a day if we're trying to figure out why tests are failing, or anything that gets shipped to a few canary hosts first, and we watch the metrics there to make sure that the numbers aren't skewed versus the production code. And so there's several places where we can stop a deploy and say, okay, something's wrong here, let's start cherry-picking things out until it looks green. But yeah, there's individual ownership of those, and your individual branch will get bounced if the combination of the release team and the other engineers in Launch Campfire sort of agree that it's probably the problem.
Do you have any kind of a code coverage or test coverage requirement built into this process formally or informally?
Depends on the team. So some teams have really strict automated coverage checking, other teams don't. Most of that actually gets covered at the code review stage rather than at the deploy stage. So you're sort of, like, if you're catching it at deploy, you're probably doing it too late. Usually if your branch is failing, the solution is not to go run more tests to cover it. It's to yank it and figure out what's broken.
So following up on the thing about you've got multiple changes going out, and somebody's not there to say yes, their change gets pulled. How do you guard against that breaking somebody else's change? Or if you've got a series of changes that have a dependency chain, do they have to go out in sequential deploys? How do you see what I mean?
Yeah. So it's basically a complex series of negotiations between the folks who want to get the changes out and the release team. So if you've got staged releases, then you need to be that much more ahead of the game in communicating early and often. This can't go out until this has gone out and this has gone out. So I would like this, root dependency to go out today. And if it doesn't, it's going to impact these other releases that are planned for later. So it's on the individual person trying to get that change out the door to own that communication and make sure everybody's aware of what the dependencies are. As far as implicit dependencies, hopefully that's somewhat hard to achieve because the branches are actually tested in isolation and then only combined when it's time for release.
So each one has to work both individually?
Each one has to work individually and in the integration branch.
Okay.
Yeah.
One last.
Yeah.
So do you rebase squash, or you're talking about like?
That is an ongoing holy war.
The real thing I was asking was, how do you cherry pick a branch like that? Do you just cherry pick?
Oh, you
all
just
the
rebuild the
components
integration branch.
Okay.
There's,
Oh, you
I mean, the
rebuild the
Cherry
branch.
pick is the wrong term.
Yeah, it's not a
Okay.
it's not a Git cherry pick. There
Okay.
is a release automation tool that, given a set of branches, builds an integration branch out of those. You
Okay.
can throw away that integration branch and build a new one using a subset of those.
Awesome.
So that's what we do. There's
That's
no
what I was
Different
asking.
octopus merge.
Yeah.
Yes.
And we're not reverting the merge and the integration branch or anything
No,
funky like
they're,
that.
they're not actually even using Git. They manage it all with Excel spreadsheets.
Totally. So now the slide that everybody's probably been waiting for, which is like, where do we hit the wall with scaling Rails as a platform for these big apps? Issue number one, with a bullet, unchallenged at the top, is the stability, memory model, and garbage collector for the Ruby VM. You just cannot pump thousands of requests per second through persistent Ruby, like MRI processes, without them falling over, bloating, corrupting memory, dying horribly. We have zombie unicorns everywhere. It's terrible. Rubinius could fix this. From all indications, JRuby actually does a lot to fix this, though moving a 500,000 line Rails app that's been around for 6 years over to JRuby is a decidedly non-trivial undertaking. But for MRI, mainline Ruby, this is just hard. C extensions make it worse, way worse, because the Ruby heap is just a big, giant, flat array of memory to every C extension, right? Like it's just sitting there waiting for corruption. We had a wonderful, this is like one of the great apocryphal stories you first hear when you start in engineering at Twitter. We had a bug caused by RMagic where it decided a string buffer that was a SQL query generated by Active Record was actually an image buffer it owned. And decided to put a null byte somewhere in it that just happened to be directly before the W at the beginning of where. So, 100 million row database table, query with no where clause. It might have been a delete. I don't know. Not so awesome. And again, all of those things that are statistically improbable for any given request, or any, when you have billions of requests flowing through the system in a given day, those become statistically very likely very quickly. So that's possible. Rails itself makes it hard when you have this huge code base, right? Like the idea that everything is implicitly auto-loaded in your namespace and things get smushed together from all these mix-ins scattered around your code base, and super cool when you've got like 30 classes in your app. Less so when you've got 500 or 2,000, whatever, right? Like just figuring out where a particular constant was defined or method was defined in your system can be incredibly hard. Even ignoring the possibility that it was dynamically defined somewhere and you couldn't grep for it if you searched your entire hard drive, right? So just the things that, all the Rails magic that makes the screencasts really fast and wonderful cause even more pain when you get over this certain size complexity boundary for the app. Which isn't to say that like good developers can't deal with that, but you end up spending a lot of time and pain focusing on that instead of on product features.
Well, and you also shouldn't have to, a requirement shouldn't be only the absolute best programmers can work on this.
Totally. And then, as I hinted at before, trying to minimize use of Active Record, you give up a lot of the magic that Rails gives you, right? Like these relationships between models that just come into being, like that's super cool and easy and goes away the minute you're using the Active Record. And I'm going to date myself a little bit here and say, like, there's probably a whole bunch of stuff you can do with AREL and Active Model and whatever in like the newest versions of Rails that totally counteracts this argument. Apologies. Again, this is based on using a bunch of existing Rails code, not whatever's bleeding edge. Yes?
Yes, I don't know if you mentioned that, you mentioned JRuby, but given you guys have kind of a big JVM deployment stack and already have that, do you guys use JRuby, especially when you take off Active Record and C extensions?
So we use very little of it. I'm actually trying to get my team to use it a lot more because I think it's our easiest compromise between potentially moving entirely off Rails and moving to something that we can at least sort of trust and support in production. But that's actually probably a bigger hill to climb for us than it is in some other places because like we have thousands and thousands of servers running a custom hacked version of Ruby 1.8.7 with our own garbage collector and whatever, and many leaders of blood, sweat, and tears have gone into getting that into a place where we know how to monitor it, we know how it behaves. JRuby is much more of a mystery to our sort of runtime systems team. They're willing to let us try, but not with a ton of support. So it's something where we're going to probably take it on in an experimental way.
What is the
see how it
Rails
goes.
version?
Sorry?
Does it vary? Rails versions, what do you?
Yeah, it varies. Everything from, I think, like I said, the 2.0 point Twitter version that's being used for a bunch of our production stuff to 3.1 something for some of the apps that have been touched more recently. Yeah.
Trying to avoid the holy war. What does Twitter currently use instead of Active Record?
A bunch of stuff, but there's not really a unified framework that we use instead. What we tend to have is actually Rails apps sitting in front of a bunch of services rather than Rails apps sitting on top of a database. So the services then manage caching and persistence and whatever, and they just give a nice RPC interface that we sort of manipulate data through. And I'll talk a little bit about that. So I promised some reasons for why, at least for even my group, which doesn't have the scaling demands that Twitter.com does, we try to eschew too much new use of Active Record. Even basic stuff like splitting reads and writes across different boxes isn't, like it's not in vanilla. Certainly sharding, and all of this, yes, you can piece together libraries and extensions and whatever to make Active Record do this, but those are of varying quality and level of maintenance, and the recommended way to do it changes every 6 months, and we don't want to pause development on our ads platform for 2 months to go port to the latest and greatest sharding gem for Active Record.
And they weren't invented here.
So, very true. We have tried many of them, and they mostly have disappointed us. It's also really easy to do dumb things with the database, right? It is super easy to drop an n+1 in without noticing it, again, because of all these wonderful things that Active Record does for you to follow relations and whatever. And 1 + n is bad when n could be up to 10,000. 1 + n is really bad when n could be up to 1 million, and it just gets worse from there. Caching, naive caching when you're using Active Record is to shove Ruby objects in your cache, which is great until your class definition changes for any reason. You add a field, you remove a field, you change anything in a backwards incompatible way, which of course never happens. So this is great, again, if you're at low volume and your cache TTL can be 60 seconds and you can blow it away on every deploy. Not a problem. If that defines your app, don't worry about it. Cache raw Ruby objects, it's nice and efficient. We have TTLs on the order of days, weeks, or years for many of our really hot object caches because we just can't afford to go to the database for those objects anymore.
All right, what's that acronym? What is it?
TTL?
Yeah.
Time to live.
Okay.
So when you put an object in memcache, you can optionally set a time to live, which is a number of seconds, after which memcache will forget it. Redis has similar provision, other caches people use similarly to do this. So if you're trying to cache it for a really long time so you don't have to hit disk when you go to read it, you can never change your class definition.
Just don't make it too long with memcache, because then it starts treating it as a Unix APOC.
Sure. Sure.
So what is the argument for a TTL longer than 24 hours, really? Because you're not going to get that much performance benefit.
Sometimes you do. So sometimes we really have data we can't hit disk for, except in a disaster recovery scenario. MySQL is like tape for us. It's like the 2 orders of magnitude slower than where we want the data to be sort of persistent store that we'll go to when we have to. And so if you have stuff that's continuously aging out, sometimes that just means you're we can bring down the site by losing a little bit of memcache, basically. Less so now than say 1.5 years, 2 years ago, but it's still possible if the wrong bank of cache goes down, because we basically try to serve anything that's in an API request out of RAM. So memcache is a common place for that. We also use Redis. We use some in-house stuff for really info-dense. But yeah, so this is basically for cheating and using memcache as an in-memory database rather than a caching layer on top of MySQL, where the characteristics of the service are such that you can't afford to go back to MySQL. Migrations, totally useless. Totally useless when you have huge quantities of data, because the first thing that happens when you go to alter table is you lock the table. So goodbye, done, go home. The site's going to be down until that's done. So, some of that's a MySQL rant, not a migration rant, but the point remains the kind of easy inferred oh, here's my schema diff, I'm just gonna let the framework handle that, just doesn't work anymore. Our migrations are double, triple checked by our DBAs. They're run during off hours, only on particular subsets of the data. They're done in staging before they're done in production. You can never trigger a migration. It's just a casual side effect of a deploy. And this is a purely aesthetic and personal argument, but having all of the critical business behavior of your class defined by an abstract superclass you inherit from is so bad. It's just now I want my model to not be an active record model. I guess I'll rewrite it because none of my logic is going to work without all of the active record magic that's sitting in the superclass. So, all right, back to more sort of process team, sort of organizational inertia. I talked a little bit about, it's easier to build into the systems you already have than to spin up a new system, right? So part of that is understanding distributed systems is harder than understanding monolithic systems. So as you add additional nodes in your distributed system graph, it gets harder to understand. So it's natural to want to build into the thing you already understand that you can keep in your head, right? There's a jump in going from a single-threaded process on one machine to a multi-threaded process on one machine to a single-threaded process on many machines to multi-threaded on many to multiple data centers. And every time you do that, it gets harder to keep it in your head. So build where you know, build where it's safe. The whole design review and security review process can add friction. Even though they're good things to do and you ship better stuff, it adds friction to building a new thing. You usually don't have to go through a design review for adding a form to an existing web app, but you probably do if you're spinning up a whole new service, a whole new set of servers, whatever. So that adds friction, which again makes it easier to just build into what you have. Deployments are easier, right? Orchestrated deployments of complex distributed things are really hard, right? Now you not only have to understand it, you have to ship unproven versions of it out and watch for them to fail. So the sort of natural result, if you're taking the path of least resistance, is you just have this mega app, mega repo that everything flows into because nobody has to learn a new process or a new system or go through a review, and then it's huge and it's impossible to understand. It falls down all the time and the tests are slow and all of the other bad things that come from that. So, true story, it peaked at 3 hours to run our test suite before we had an effective distributed test running.
Effective what? What was the last?
A distributed test runner. So now we have a cluster of machines that run our tests, and it's a few minutes to submit and let it run on that whole cluster and give you back your results. But it did get up 2 hours. We did the whole make sure everybody has the fastest laptop, make sure everybody has an SSD, make sure everybody's got a spare box under there, and eventually you still just hit a point where you have to run them in a distributed mode, or ideally break the system up into lots of little pieces that you test independently. Briefly on the not even to here thing, when you've got all these sort of autonomous teams and they're nominally working on the same stuff but doing it independently, it's really easy for them to reinvent and re-implement the same things. So, code sharing is your first defense against that. If someone else has already built it, so much the better. That cuts short a bunch of argument over how you're going to do it. Internal libraries, gem in a box is great if you're doing stuff in-house, have a place to just manage your dependencies that way. And services are sort of the ultimate version of code sharing, right? Where you have a backend service you're calling into, that's basically taking a library, wrapping it in an RPC layer, and saying here, use this, and then you're completely decoupled from things like versions. You don't need to know. It's oh, somebody deployed that, but it's still running, and it still honors the interface we had. Capacity, scaling, whatever, they handle that, right? So that's great if you get to that point.
I was curious, do you have a standardized protocol for your RPC
Thrift.
for all the different services that
Thrift.
you're using?
Yep, Thrift all over the place. So Thrift is an open source RPC framework that Facebook built and uses heavily and open sourced. It uses an interface definition language that's, if you've read any IDL of any type, it kind of looks like that. You define structs that hold data and methods that take various structs and return various structs, and it has exceptions, and that's about it. And then you run the Thrift compiler over that interface definition, and you get stub code for both the client and server. Actually, the client code is fully featured, knows how to call into the servers. The server code is a stub, and you go implement the methods that are in the definition. We use it all over the place. We use it for RPC. We use it for data persistence, because the binary format's actually pretty efficient. So we'll pack up an object and then just serialize it through Thrift. That's how a lot of our logging gets done. Actually, we'll build a Thrift object, shove it into a log record, and then it goes into HDFS, and then we've got it for future use. So yeah, we use Thrift everywhere for service boundary stuff. This is just a catchphrase from a number of teams that I've been on, where like you use this flag, like, oh, this isn't suitable for our needs. And to your point, it's sometimes you use that and it's true, and sometimes you're using it because you just don't want to deal with a slight impedance mismatch in the interface. But one of the most common questions from somebody who's new on my team is, who do I talk to? I've got a change I want to make to this shared code or this service. I've already made it. Who do I talk to get them to review it and tell me if it's reasonable? Owners files help if they're used universally and if they're kept up to date, but they never are. So you need the sort of organizational knowledge documentation somewhere that tells new engineer X that not so new engineer Y is the owner for this system that they're hacking on.
You should tie that into like a review, things. So when it comes time for your end of year review, what owner files are you in?
Mm-hmm.
Oh,
that would be interesting. That would be really interesting.
You change it to a completely different problem.
Right.
Yes. You're responsible for this.
Yeah, I mean, we do it. There is actually a bunch of stuff we do to like try and keep people in a cadence of doing enough review and doing a good job of it. We have dashboards up in a lot of team areas that are like, here's the oldest reviews waiting for someone from this team to look at them. Here's the folks who've submitted the most reviews this week. Here's the folks who've done the most reviews this week. That kind of like info dashboard is actually pretty useful.
The people are going to be looking for a job next week.
And then one thing that's kind of nice, even for the scale that we operate at Twitter, is that there's a whole bunch of, like, we're enough years behind some of the other players like Google and Yahoo and Facebook at getting really huge, that they've written a ton of papers and code and stuff that we could look at and go, oh, that's how you build a fast in-memory distributed key value store. Awesome, we're just gonna go re-implement that. It is invented here, but not actually invented, it's just implemented here.
Yeah.
Somebody else already invented it and talked about it. So do this shamelessly wherever you can, right? Like even if you can't get their code, if they've published a paper about how it was built, you can probably save yourself a lot of time.
Unless it's Apple.
There is a joke that has some pain behind it that you will hear, not just at Twitter, but some other places in the San Francisco area, which is that Cassandra is actually a poison pill Facebook created to penalize all of its competitors when they got to sufficient scale to need it. I'm not saying that's true, but it's funny. So getting back to metrics, I alluded earlier to the fact that you can't tail log files, you can't even identify discrete individual events all the time that are causing a failure, because you get to so many data points that what failure becomes is probabilistic, right? Like it's not a single observable event, it's your success rate has gone from 99.95% to 99.83%, which tells you that something must be broken, and it must be something that was broken in the time it took that metric to change. So that's how you go, like, do your root cause analysis. So there are core metrics you should absolutely be getting, and if you're using New Relic or equivalent, you're going to get all this stuff for free. If you're doing it at a really big scale or with a really weird stack, you may have to do it yourself. But things like success rate are awesome. Just have like a 3 significant digits readout like in the middle of the Eng team's work area showing the basic success rate on the API. Page load time is also good. Although what you really want is like how much higher or lower is this than it was a week ago, maybe more than a discrete value. And then some really useful stuff. Say you've got backend services you're calling. Capture the round trip time for those. Know how many read-write ops you're doing per second, right? Like that number shouldn't really change dramatically except as a function of page hits, right? If it does, otherwise, something is probably wrong. Message queue size. This is probably the most standard alert that I see from our internal monitoring systems at Twitter. Is this message queue is now over 500,000 items. Because that means something that's consuming that message queue isn't working anymore. And when in doubt, log everything. right? Disks are pretty cheap if you don't need to be able to do anything with the data fast. But if you can just throw a bunch of raw metrics onto slow spinning Rust, and then go mine it later at your leisure when you have to do forensics, that's great. And it can save you time. Yeah.
Do you also watch for message queues being below the normal size?
Not usually.
Because I've seen that.
We usually want them to be pretty close to 0.
So, or throughput is another thing.
Sure.
It's like, hey, this message queue looks really healthy. Huh? Nothing's passing through it, but
Sure. Yeah. Messages passing through is a thing you want to watch, and certainly you want to watch for the case where the queue is being drained by a consumer that's dropping every message on the floor, right? So, time to process. You don't want to see that like spike up or down too much either. Yes.
What kind of tools do you use to accomplish all those?
So we have some in-house systems that do a lot of this metric stuff. There are some really great open source options if you're not doing a billion writes a second. We have a bunch of stuff that does a billion writes a second, or a minute, something in that order. It's probably a minute, but it's, so that's pretty specialized. If you're doing anything close to the JVM, Coda-Hale's metrics library is really good, and there are a bunch of Ruby clones of it at this point. There were 3 or 4 that got thrown out when I was at RailsConf last year. It's been pretty good, but not one clear winner, so I wouldn't speculate on which is the right one to use today. But yeah. But it is worth finding a good metrics library because there are things that are actually kind of subtle in the record keeping. Like you want a sliding window average and how you do the sort of reservoir sampling and averaging of that. You want that math to be right, or it can mask things that are actually not working well. So I would encourage you to find something that's already been built and use that. And again, there are many hosted and service provider sort of ways to do this. It's not an option for us for a lot of our main API and web traffic, just because of scale. Like us talking to another data center at that scale is off the table. And then just a couple of notes, because I've talked a lot about how we've sort of decomposed stuff into services, and that can seem all easy and sweetness and light, but there are some things there to potentially trip you up. As I said, one cool thing about it is it's in some ways like the highest sort of level of abstraction you can put on some system you're using, is now you have a service boundary. It has an interface that is a contract. It can't touch the data that's in your memory, and you can't touch the data that's in it. And you can be independent of a lot of the version dependency, coordination of deploy, like that kind of stuff. Transports. Probably no one in this room is likely to start with XML anytime soon, but once upon a time, this was where you started if you were building a service that talked to some front end. For most applications, it is strictly worse than using JSON. And once you're talking about anything at scale, JSON is strictly worse than using a binary transport. And the main reason for that, and this is potentially controversial, I'd be happy to argue with people over beers about it, but the main reason I make this assertion is that unless you are using some JSON plus schema system, like Avro gets close to this, a few other systems do this, but unless you are using JSON plus schema, the odds are very good you're going to be streaming data of arbitrary format back and forth through your services, and if your service contract changes but the code doesn't get updated somewhere, you're not going to find out about it until the message actually starts flowing through the production service. So with a binary transport, you usually have some sort of interface that you're coding to, and the binary transport encoder and decoder will blow up if you try and put an object through it that doesn't match that interface. So you can accomplish this with test coverage, but only if your tests evolve in lockstep on the server and client side of your service. With a binary transport, like the protocol handler will not let you pass like a version 2 message to a version 3 server, or vice versa. Yes?
What kind of binary serialization are you using?
We're using Thrift. We have used protocol buffers just for storage in some places, mainly because they do recursive structures and Thrift doesn't. But for the actual RPC stuff, it's almost all Thrift. Yeah.
So I would go even further on the JSON and say you're probably not shipping what you think in the format you think you're shipping it. And if you statistically sit down and with people looking at things, it's amazing how frequently the people who are using and consuming it, it serializes that shouldn't be in there, or I thought that was an inner.
About using Thrift or another like strong binary transport for this stuff is, I mentioned before, we tend to take a lot of Thrift objects and serialize them in log messages. And one thing that makes that really easy is, so I've built a service, it takes some Thrift struct in its request, I'm just gonna log that whole struct. That's gonna be what I shove aside into my log file if it's a request I care about. And you don't have to do translation between a log format or a text format, and you just say, oh, hey, object I've got in memory, make yourself a thing on disk that I can read in Ruby, Java, Python, C, whatever, right? So that's nice. And it gives you some future proofing. Maybe you go prototype the service in Ruby, and then you build it in Java or C++ when you hit volume. And it's the same interface, same serialization logic, all of that stuff.
So you're storing it in binary format?
A lot of the time, yeah.
Okay.
Yeah. Yes?
One last tackle. Where would you put YAML?
Having honestly never built an RPC service that used YAML over the wire, it would be reckless for me to speculate. But I would probably put it somewhere closer to here. With an extra giant danger Will Robinson sign due to the arbitrary object serialization and deserialization that's just shipped out of the box. JSON, at least, it's harder to do that too.
What about using BSON between, or is there just not related?
So BSON, the problem is BSON still doesn't solve the schema validation problem, right? So the binary packing is really good, so it might be fine as an archival storage format. But unless I can take a BSON blob and a definition of what it's supposed to look like and get an exception if I try and mash them up in an incompatible way, it's kind of I get nervous. So Thrift gives you that at least as a wire protocol for RPC. So yes.
So you wouldn't care so much about JSON if it had schema validation?
I wouldn't care so much about it. I still don't know that I would choose it over Thrift for anything that was operating at volume, just because Thrift has really nice, highly tuned parsers and emitters for N different languages. But yeah, Avro is basically that, right? It's like JSON with annotations for what should and shouldn't be included. And we used that for a bunch of things. It just took a bunch more compute time than Thrift, and it didn't support as many languages. So other reasons to do service decomposition, performance and capacity planning get easier to manage. You no longer have a single app that has to handle all your capacity. If you discover that this one service is a hot point, provision more servers for that service. And you don't have to over-provision the rest of your app to handle that extra load. And you can observe performance just on that one particular service. One other a thing that started as an in-house project that we've since open sourced is a tool called Zipkin. It's a distributed tracing tool that'll sort of give you the full timeline of service requests, starting from your web server back to your storage engine and forward. You have to do a lot, you have to explicitly annotate everything your code is doing to get those traces. It's not magically hooked into all of your frameworks, but it is a thing that you can use to sort of get some handle on what the total system behavior is.
Any example services that most people wouldn't gather that you had?
Well, so the two I mentioned before were, we have a tweet storage service, we have a timeline storage service. A service my team deals with a lot is a system called Rainbird that's just a time series counting service. So it basically consumes out-of-order log messages saying this event happened at this time, and then builds buckets of aggregated numbers for minute, hour, day, how many of those events happened in that bucket, and it's consuming billions of those records in a minute and turning it into these buckets, and then has a query interface to go say from January 1st to January 15th of 2013 in each hour how many of these events happened. And so we use that for analytics dashboards and metrics.
Where'd you write that?
That's a Scala service sitting on top of Cassandra. And Cassandra has been the source of much pain in keeping that service running at scale. So the flip side of all of this SOA wonderfulness is that testing is harder. I talked earlier about needing dummy versions of the services, whether they're in process or actually network daemons. Observability is harder, right? Coordination of deploys, updates, that kind of stuff can potentially be harder. There are small changes that are totally compatible that are easy to do because it's totally invisible to your consumers, hopefully. There are big changes where you actually want to change the interface or over the wire format. Now you have two projects that need to get updated sort of in lockstep. a big part of how we deal with that is actually having multiple versions of the service running in production at the same time, by basically teeing off any writes, and then we can sort of migrate reads over gradually, and once everyone's reading off the new system, then we can stop writing to the old one. Yes?
And couldn't you solve that with just versions in the API calls that you're making? So, you know, where
Sure.
.com/v1. Couldn't you
Yes.
so you don't have to have multiple versions, so it's only one version running in answer all formats?
Sure. If you want, the problem there just becomes actual, like, either you have conditional logic in your service that says like, oh, this is an API v1 request, I'm gonna route it over here, this is an API v2 request, I'm gonna route it over here, or more commonly what we end up doing, which we have done in some cases, is have a sort of proxy that sits in front of the service that knows how to look at the payload and decide, oh, this is going to legacy server, or this is going to new prod server, or this is going to data center 2 server. You can totally do all of that. It adds a little bit of complexity. We mostly deal with evolution of the RPC interface by sticking to some best practices for Thrift, which basically say you never remove fields, and you just sort of add new ones onto the end of the structs, and you never remove methods. You can deprecate them, but never completely drop them. And there's ways to sort of forward evolve an interface that you don't usually have to actually break compatibility with old clients. The more common case for us is literally, hey, we have this new storage subsystem that's like 5x faster. We want to rebuild this service on top of it, and we want to test that for a while before we flip the switch for everything. I think that's it. So, if this sounds like anything other than a giant shit show, please come talk to me, because it is actually a lot of fun, and we are always hiring. And I would love to have more Rubyists in the building. Like, people think we don't use it, and we do, and it would be great. Any more questions? Yes?
Kind of about the service-oriented architecture. Do you have any sort of service discovery services?
Yes.
Kind of like Zookeeper.
We use Zookeeper.
Okay, Zookeeper.
Yeah, and we have some additional client and server sort of libraries to do sort of automated registration and management of server sets. So you can basically just say, hey, I'm an instance of X, and you'll get added into the pool, and Zookeeper handles the sort of broad, sharing of that data. It's just sort of a mesh to get that information out. But yeah, we use Zookeeper pretty heavily.
Cool.
Yes?
So I thought I heard you mention that when you log, you will log an object like in a format, like in a readable format.
Mm-hmm.
Can you read that format back into an object?
Yes.
Okay, great.
I mean, that's something that Thrift just gives you. The Thrift library that you use in Ruby or Java or C or whatever knows how to marshal the binary formats, because it's using the same binary representation it would use over the network to shoot an object over to a service. So it's just, you take it as far as generating a string from the object and shunt that off to disk or the log stream. Yeah.
So Thrift, though, implements a subset of these semantics. You couldn't have any sorts of, like if you had a lambda
Right.
as a
Yeah.
thing. So how do you enforce that? You just discover that when you try to serialize it, that it's not compliant, or how do you enforce compliance?
That's basically library code that just says, I'm going to log this record, and it does it through Thrift, and the class you're trying to serialize is part of the call into the Thrift library. So if you say, I want to serialize a tweet service request object, and you pass it a Ruby hash, it's going to fail the type check and refuse to do it. And it's not duck typed or anything. It's like you have to have an instance of that Thrift object to serialize it. Because in most of the languages, we have Ruby over here, but then we have C++ and Java and Scala and everything else that are actually doing the sort of type check ahead of time. Yeah.
Are you doing any distributed teams or distributed pairing? And if so, does that add complexity or
Sure.
make it better?
Not a ton, but we are doing it. About 20% of my team is remote. And we're not doing distributed pairing very much. We don't actually do a ton of systematic pairing as an organization. There are teams or individuals who really like it, but we sort of lean more on the code review stage rather than the initial authoring stage to get that many eyeballs sort of support. And for remote teams, like the launch campfire that I mentioned can be an issue. There's a guy on my team who spends a month or two a year in the UK, and for him being in that campfire room during West Coast business hours is a little bit of a stretch. So when he's going to be there, we find projects that don't have to go through the main Twitter.com or API release queue, so that he can be a little more autonomous. And we're getting better at it. You know, we just historically most of our engineering resources have been centered in San Francisco, so we haven't had to deal with it except as one-offs. Folks may have seen we bought a couple of companies in Boston in the last week or so, so we're now going to have a bunch of engineers working out there full time, and we'll evolve sort of practices as we need to make sure those folks are successful.
We get a lot of tests that fail when you run them outside of DC time.
Time and time zones and dates are evil.
Evil.
Pure evil. Yeah. Total pain in the ass.
Convert it to UTC as it comes in, and convert it when it goes back out.
Right. Well, I mean, the system I mentioned that we use for analytics, right, that does daily roll-ups of analytics.
What day exactly? Yeah.
Yes. Day is in the eye of the beholder, so that's always fun. Yes.
Do you use Thrift for any data that originates outside of your control, or is it all for internally produced data?
We don't consume any thrift from outside the firewall or send thrift out of the firewall. Everything that goes to, you know, an external API partner or whatever is usually in one of two formats: JSON, which is what we prefer, or more commonly, as we deal with other big companies, CSV. The sort of universal data interchange format that everyone, you know, it's like the lingua franca of data exchange.
Because they're putting.
It's better than fixed column like that.
Totally.
Yeah.
We did
Extremely better.
we did a project with Nielsen. It was terrible. Like, yes.
Pictures.
Yes.
I was wondering, I'm assuming there was probably a point before you were using Thrift at Twitter, and at that point were you using like internal APIs to talk between applications or different services?
We didn't really have a ton of synchronous APIs, like call response, sort of synchronous RPC stuff before we adopted Thrift. What we had, and I sort of had this in the like stages of grief/growth thing, where it's like first you do some caching, then you do some queuing.
Yeah.
And so what we had was a lot of JSON shoved into Kestrel queues, and that sort of became the asynchronous RPC layer for a lot of systems. And that sort of plugged the hole for a while. And then by the time we were doing synchronous RPC calls, with the exception of a couple of early experiments we did with Avro, which sort of worked but basically didn't, we pretty quickly standardized on Thrift.
And will Thrift also tie in with something like a memory backend, like Memcache or anything?
Not out of the, I mean, all Thrift does out of the box is say, I have an interface with these methods, and I'm going to generate a client binding that will give me a sort of object that hides the fact that I'm making network calls to invoke those methods, and a server stub where I go implement the actual logic. You know, you have to, if you want caching in there, if you want it to talk to a persistent store, if you want it to do anything else, that's on you to implement. And you know, you can do that by spinning up, you know, your Rails environment with script runner and giving it a Thrift daemon implementation in Ruby, and it has access to all your Rails logic if you wanted to do that, just to isolate web requests from some backend service. We more commonly do the backend stuff in Scala or Java, so there's just completely different frameworks for that.
Did you say that you guys are moving more towards synchronous RPC? So do you still use asynchronous RPC?
Oh yeah, we use Kestrel all over.
So do you still use Thrift?
Yeah, it's not asynchronous RPC. It's just work queues. Yeah. Work queues with tons of fan out child queues. That's like it's one of the wonderful and terrible things about Kestrel, that you can connect to a Kestrel cluster and say, I want to connect to, you know, qx/foo, and child q foo magically comes into being and gets a copy of every message that's sent to X, which is really great, except when you do it on your development workstation just to try something out for a while, and then you Control-C that script, and then x/foo continues to fill up, and I get paged because the guy on my team has now put 40 million messages into that queue and it's not getting there. But no big deal. Yes?
It seems like you have a fair amount of like code base and things for its internal use. Just like managing all your different services and like logs and stuff like that. What would you say your like
You mean in terms of like engineering time that goes into user visible features versus sort of internal infrastructure engineering, or? It's probably about 50-50. Maybe even more like 40-60 consumer versus infrastructure. We invest really heavily in infrastructure because it's not just that we're like building services once, it's that as we grow or usage patterns change, we have to occasionally like completely rebuild them to get better efficiency, better consolidation, you know, that kind of thing. So yeah, we've got a really big sort of platform, infrastructure, and ops sort of side that consumes a lot of. Yes?
I was wondering on like a non-technical level, where you sort of see the cultural impact of Twitter, like currently and where it's going from your perspective as an engineer?
So I guess where I see it sort of going is just as I mean, for me, it's the replacement for RSS, right? It's just where I get all of the topical sort of focused streams of information that once upon a time I would have consumed via RSS with the sort of pushback channel that never really existed for an RSS universe. And the payoff for accepting that as a centralized thing is that we can do a lot of stuff to help you find channels, to keep the bad stuff, the spam, the malware and stuff out of it, to sort of make the units of content richer, and to spend a lot of time and money on making sure the stuff's flowing, right? Like one of the classic things when everything was flowing through RSS was like, oh, this blog switched from RSS to Atom, and like the URL changed, and I guess they're gone now, like until I find that out and like resubscribe. So there's, for me as a techie, I see the value of Twitter being just sort of this universal messaging fabric that maybe, again, happy to argue over beers with folks if they want to talk about sort of specifics, but that's my rough sense. Yes?
From the management point of view, with the owner files and the code, how do you keep that from being overly self-perpetuating, where somebody is always being asked to spend their time on a particular thing, versus the other extreme where everyone might be expected to jump into anything? How to keep that medium?
Constant compromise and struggle. There's not like some people really want to be on 15 code reviews a day because they really care about how systems are evolving and they want to have visibility into that.
But if you're their manager, you want them to write some code too, not just sit.
Oh no, I think code review is super important. If somebody like writes code 1 or 2 days a week and does code review and mentoring the rest of the time, that's awesome. I want to promote them. I mean, writing code is great too, but like a lot of what we're looking for in
thinking is great.
Yeah. Thinking well, and benefiting the whole team rather than just sort of being like the lone gunman coder, like is awesome.
Yeah, if that one person spending all their time on code reviews makes everyone else more productive, they're actually more valuable, not less.
Yeah, it's sort of up to individual motivation, like what drives that particular person. There are folks on my team who want to read every code review that touches the data model, right, where like the schema might evolve. There are folks who want to read every JavaScript change, and there are folks who really never want to do code review. They want to ship new stuff 3 times a week, and it's about just finding the right types of projects and responsibilities for each of those folks.
Huh. That's interesting.
What about people that want to remove code?
Just go.
Those are the ones I want.
Some of the best review board threads have been, somebody who posts a 5,000 line negative diff, right? Like, I'm just expunging this subsystem because we don't need it anymore, and like people show up with whiskey and hugs. Yes, ship it, do it. And there's actually a good technical reason for it, which is Ruby ASTs live in memory forever in your process, so you actually save heap space on all of your servers by deleting old code.
There's an even better technical is that you very seldom encounter bugs in code that doesn't exist.
Very true.
Bugs need code to hide it.
Very true.
All this box needs to do.
All right, awesome. Thanks, guys.